This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today we're diving into the fascinating world of interactive physics simulations, specifically focusing on a resource called Accelerated Platform with Cylinder. It's a JavaScript applet designed to enhance learning in dynamics and rotational motion.
Indeed. These interactive simulations offer a powerful way to visualize complex physics concepts that can often be difficult to grasp from textbooks alone.
Absolutely. The visual aspect is key, but what makes this particular applet stand out?
Its interactive nature. Students aren't just passive observers, they actively manipulate variables and see the immediate effects on the simulated system.
So it's not just about seeing the physics, it's about experiencing it. Let's explore the details. Let's start with the overall purpose. What are the main themes and key ideas behind this accelerated platform with cylinder simulation?
The core theme is active learning. The applet aims to make learning dynamics and rotational motion more engaging and intuitive by allowing students to experiment with different parameters such as acceleration, mass, and friction, and observe the resulting changes in the motion of a cylinder on an accelerated platform. It leverages the accessibility of JavaScript and HTML5, making it easily embeddable in web pages.
So accessibility is a key feature. It's part of an open educational resources initiative, right?
Precisely, it's freely available for educational use, promoting wider access to quality learning materials. The Creative Commons license ensures that educators can adapt and share it, fostering collaboration and innovation in education.
Let's delve into the applet's features. What kind of interactive controls and visualizations does it offer?
The applet provides a range of interactive controls. Users can adjust parameters like acceleration, velocity, and time step through editable field boxes. They can also toggle the display of various quantities such as velocity vectors, acceleration vectors, and normal force. Visualizations are dynamic, showing the cylinder's motion in real time. Standard controls like play, pause, step, and reset are included, allowing for careful observation and experimentation. And of course, it supports full-screen mode for a more immersive experience.
The ability to control the time step is particularly useful for details analysis, isn't it?
Absolutely. It allows students to slow down the simulation to observe subtle details or speed it up to get a broader overview of the motion.
What are some of the key learning goals that this applet aims to achieve?
The applet helps students understand the relationship between force, mass, and acceleration in a dynamic system. It allows them to visualize the effects of different forces on the cylinder's motion, including the normal force and friction. It also helps them grasp at the concepts of rotational motion, such as angular velocity and torque. Furthermore, it encourages students to think critically about frames of reference, comparing the cylinder's motion from the perspective of an observer on the platform versus an observer in an inertial frame.
So it's not just about memorizing formulas, it's about developing a deeper conceptual understanding.
Exactly. The interactive nature of the simulation fosters intuitive learning, allowing students to build their understanding through experimentation and observation.
How easy is it to use the applet? What are the key instructions for both teachers and students?
The applet is designed to be user-friendly. The instructions are straightforward, guiding users through the various controls and options. Teachers can easily integrate it into their lessons, using it as a demonstration tool or a platform for student-led investigations. Students can explore the simulation independently, experimenting with different parameters and observing the results. The embeddable iframe makes integration into learning management systems or websites seamless.
The ease of embedding is a significant advantage for educators.
Absolutely. It streamlines the process of incorporating the simulation into existing learning environments.
The website features many other simulations and resources. Can you tell us more about the broader context of this applet?
This applet is part of a large collection of open-source physics simulations and educational resources. The website offers a wide range of interactive tools covering various physics topics, as well as resources in mathematics, chemistry, and biology. This comprehensive collection provides a rich learning environment for students and teachers alike. The use of easy JavaScript simulations, EJS, as a develop me framework is also noteworthy, highlighting the platform's commitment to open source tools and collaborative development.
The breadth of resources is impressive. It's a valuable hub for educators.
Indeed, it fosters a collaborative environment where educators can share and adapt resources, enriching the learning experience for students.
Who are the creators of this applet and what are the licensing terms?
The applet is credited to Juan M. Aguirre-Gaviria, Fremont Teng, and Luke Kang. The content is licensed under a Creative Commons Attribution Share Alike 4.0 Singapore license, promoting open access and reuse. However, commercial use of the underlying easy JavaScript simulations library requires a separate license.
The open source nature encourages collaboration and adaptation.
Precisely. It allows educators to modify and extend the simulation to suit their specific needs and teaching styles.
Let's step back and discuss the broader role of simulations in physics education. How does this applet exemplify the benefits of using simulations?
Simulations offer a powerful way to bridge the gap between abstract concepts and concrete experiences. They allow students to visualize complex phenomena, manipulate variables, and observe the consequences of their actions. This active learning approach fosters deeper understanding and retention compared to traditional methods that rely solely on lectures and textbooks. The accelerated platform with Cylinder Applet is a prime example of how simulations can enhance engagement and promote a more intuitive grasp of physics principles.
The hands-on aspect is crucial for effective learning.
Absolutely. It transforms passive learning into an active, exploratory process.
How does a simulation help students understand Newton's laws of motion, particularly in non-inertial frames of reference?
The simulation provides a dynamic environment to explore Newton's laws in both inertial and non-inertial frames. Students can observe how the motion of the cylinder appears different from the perspective of someone on the accelerating platform compared to someone standing still. This helps them understand the concept of fictitious forces and how they arise in non-inertial frames. By manipulating the platform's acceleration, students can directly observe the effects on the cylinder's motion, reinforcing their understanding of Newton's second law.
The ability to visualize fictitious forces is a significant advantage.
It makes a complex concept much more accessible and intuitive.
How could educators design experiments using this applet to explore specific relationships, such as the relationship between platform acceleration and cylinder motion?
Educators can design a variety of experiments. For example, students could systematically vary the platform's acceleration and measure the resulting motion of the cylinder. They could collect data on the cylinder's velocity, acceleration, and angular velocity, and then analyze the relationships between these qualities. This hands-on approach allows students to develop their experimental design skills and data analysis capabilities. The simulation's ability to control the time step allows for precise measurements and detailed analysis.
The data collection and analysis aspects are valuable learning experiences.
They develop crucial scientific skills beyond just understanding the underlying physics.
How does using the simulation compare to other methods of teaching dynamics and rotational motion, such as traditional textbook problems or hands-on experiments?
Simulations offer a unique blend of the benefits of both traditional methods. Unlike textbook problems, which can be abstract and challenging for some students, simulations provide a visual and interactive representation of the concepts. Compared to hands-on experiments, simulations eliminate the complexities of setting up and conducting physical experiments, allowing students to focus on the underlying physics. However, hands-on experiments are still valuable for developing practical skills. Simulations can complement these methods, providing a flexible and engaging learning experience.
It's about finding the right balance between different learning approaches.
Exactly. Each method has its strengths, and combining them can create a more effective learning experience.
Are there any limitations to this applet or areas where improvements could be made?
While the applet is a valuable resource, it's important to acknowledge its limitations. It's a simplified model, and certain aspects of real-world physics, such as air resistance, may not be fully represented. Future improvements could include incorporating more realistic factors or expanding the range of parameters that can be controlled. Furthermore, integrating more sophisticated data analysis tools within the applet itself could enhance its educational value.
Acknowledging limitations is crucial for responsible use of educational tools.
Absolutely. It's important to understand the strengths and weaknesses of any learning resource.
In summary, the accelerated platform with Cylinder Applet offers a powerful and engaging way to teach dynamics and rotational motion. Its interactive nature, accessibility, and integration within a broader collection of OER materials make it a valuable tool for educators seeking to enhance student learning. That was a great discussion. Thank you for your insights.